David, how's the season today?
Sorry?
Season in French? Season.
The season is, you are going to autumn, so temperature is around 15 degrees, and today it was a little bit raining, you know, but just, yeah, but it's not very
maybe
hot.
winter around November? Winter,
yeah,
around November, December?
No, really, December, January, February, March. Yeah, because till the end of mid of December, it's autumn, you know, autumn. So it's not really very cold. Where I'm living, you know, I will show maybe I will show to people where I'm living before to start. What do you think, Najib?
That's good. That's good.
Yeah. I will use Google Earth for that.
Yes, of course, people, participants want to know, but where you live, and then what the circumstance, so we can see the condition in France. Yeah.
Okay. Well, don't hesitate to tell me. So, could you see? Did you see the screen with the Google Earth? Yeah.
Yes. Oh, Google, yes.
So you tell me when I have to start, okay?
Okay. Mas Reddy, mungkin bisa dimulai, Mas?
Siap. Kita mulai, Pak, ya?
Ya.
Oke, Assalamualaikum warahmatullahi wabarakatuh. Good evening, good afternoon, everybody. To all lecturer of Geological Engineering Department, all participants, and Dr. David Menier, Rizkiawan speaking here. It is my pleasure on behalf of Geological Engineering to welcome all of you in this webinar series. Can everybody hear me clearly?
Yes, very clear, Mas.
Okay.
Yes.
Okay, we are in a different time zone right now. It is 1:30 in Semarang, and it is approximately 9:30 in France, in David's time zone. Is it correct, David?
Yeah, 8:30.
8:30 in France.
Yeah.
Okay.
Yeah.
Okay. Therefore, thank you very much for your time today, David. Hello, welcome. In this COVID-19 outbreak situation, I hope everybody doing well, stay at home, and keep our physical distancing. But first, I would like to introduce Head of Geological Engineering and Secretary of Geological Engineering attending today's meeting, Pak Najib, welcome, and Pak Thomas, I think it's already here. Hello, Pak Thomas. And the rest of Geological Engineering lecturer that also attending today's meeting. We are honored to have Dr. David Menier today. Some of you may already know him, but let me share a little bit some of his summary briefly. Okay, David is Associate Professor at University Britannia Sud, Southern Britain. He got his PhD in 2003, and in 2011 he held his professorial diploma. His main research topic is focused on interplay of tectonics, sediment supply, and climate, and controlling the stratigraphy of basins. As for your information, this lecture is the first from 5 lecture series about marine geology and stratigraphy. Today's lecture will mainly focus on geology in Southeast Asia, then what marine geoscientists are looking for, and then marine sedimentation, and then geological process at the coastal area. So before I head over to David, please allow me to give you some rules in order to make this lecture run smoothly. I would like to get your attention for a moment. First, I recommend to all participants to mute the microphone or audio and switch off your video during the explanation from presenter to maintain good connection. Second, the presentation may be recorded for rescreening in the future. Third, if you have any question, we will have a question and answer session after the presentation for about 30 minutes. You can find ask and question directly or using meeting chat by writing your name first, followed by your question. This lecture also stream live using a YouTube platform. If you are watching this from YouTube, you can also ask your question using chat box next to the video box. Before we start, because this is the first series of the visiting professor program, I would like to invite Pak Najib to give some speech and open this meeting officially. Pak Najib, the time is yours.
Thank you very much, Pak Reddy. Good afternoon, everyone, and good morning, David. Thank you for coming. Geological Engineering Department, Diponegoro University, has a world-class university event in this year. We invite four professors, namely Associate Professor David Menier from UBS, France, and then Prof. Magali Coach from Boston University, USA, and then Prof. Kawasaki from Hokkaido University, Japan, and also Prof. Yusufuku from Kyushu University, Japan. This event will be held on middle of September to the end of October 2020. And today is a kick-off event, and this is the first webinar series. The objective of this event are increasing the number of foreign lecturers in Diponegoro University. By lecturing from foreign lecturer, we hope we can get sharing knowledge from reputable professor in geology and also in geotechnical engineering field. I quote from B.B. King, "The beautiful thing about sharing knowledge is nobody can take it away from you." So we can share and there is nothing to lose about our sharing. Another objective of this event is conducting workshop about how to write papers. By the workshop, we can enhance capability of writing paper in the reputable international journal. I deeply hope you can join this event from start to the end, so we can get valuable knowledge and also experience from all invited professors. Thank you very much.
Okay, thank you, Pak Najib. So, without further ado, and to all participants, enjoy your time. Please welcome Mr. David to deliver the presentation. Okay, David, the time is yours.
Okay. Thank you so much, Paredi and Pa Najib. It's a pleasure for me to share with most of the students and colleagues from UNDIP. So the best should be to be in Indonesia in order to share and to see everyone. But by the way, and by today, we can use all the techniques and continue to share with all people everywhere on the world. So this is good as well. I would like to start to show to you from Google Earth where I'm living. So as you know, I'm French. So but my English is not the best English. So if you have some problem with my accent or anything else, don't hesitate to stop me and ready help me if people need to understand or if I have to repeat or etc. Okay, I trust you about you. Don't hesitate and feel free with me. So I'm living at Van. Van is a very small city if we compare with Semarang in Java. Very small city, around 60,000 inhabitants. So close to the sea, as you can see on the southern part of Van city over there. So I'm not living very close from Paris, because maybe you know a little bit about Paris. Paris is over there, so on your right side. So Van is located nearby the Bay of Biscay and not so far from UK, not so far from UK, and London is somewhere here. So when I'm going to Jakarta and Semarang, I'm going from Paris, of course. I'm taking the train from this Rennes, and I'm going from Van. So it's around three hours by train, and after that, almost 12 or 13 hours by plane. Hopefully, I would like to join UNDIP next year and to continue to work with the Geological and Engineering department with Najib and all the colleagues that I know. Maybe you don't know about that, but I came first time at Semarang, invited by ITA in 2010. And I came in Indonesia maybe 5 times or 6 times, so I have the chance to know a little bit about your country. And in Indonesia, I'm working as well with some colleagues from Bandung, Franto Novico from the Marine Geological Institute, and hopefully we will work together with UNDIP as well next year. So if we are going to Semarang now, so you are most of you there. So it's a long way, and we are crossing different landscape, different climates, and we are going to Semarang. So, and you know where we are there. So it's like I know the place a bit. So I'm so happy to share today my first topics. And as you know, probably Najib has explained to you, we start with some introductions. We will go later on to some knowledge about coastal dynamics, and later on we will go to stratigraphy. Ready? Could you tell me if it's okay when I'm talking, if everybody can understand, etc.? Or Najib, could you hear me?
Yeah.
Is it okay like that?
Yes, of
Najib?
course. Very clear.
Okay.
Yes,
okay.
very clear. Yes.
Okay, thank you. Okay, so I will start with the first. So I have to change that. Let's see. Okay, I will start with one topics about coastal geology, coastal dynamics, coastal stratigraphy. Before to go to many details, I will propose very short introductions. So maybe we will take 1 hour for that, and in order to take time. So I would like to start and to come back about the structural context in Southeast Asia. Even when we are talking about the coastal dynamics or the evolutions of the shoreline, every time we need to have a global view, and we have to see a local zone, but to integrate in our mind that the regional setting depend about history, a geological history, very complex sometimes, but we need to have this background. And later on, I will share with you. Oh, sorry, sorry about that. I will show you some details about Southeast Asia, and I will go to marine sedimentations to introduce some concept, and we will go with some document and diagram and figures focusing about controlling factors that we need to know in order to understand all the depositional system that we have in Asia or around the world. Okay, what happened? Okay, as you know, I will not read, of course, this slide because you have already my PowerPoint. Everybody now want to understand, or maybe sometime to help, or to try to continue to live nearby the sea. And by today, we have some questions because everywhere from USA or Brazil or Indonesia or France, everybody want to live nearby the coast. And we have some questions about that. And as the population is increasing, we have some problem and questions that engineer from geology or engineer from all the topics has to do in order to help people about all the pressures and the hazard that we are recorded every days, and the frequencies about hazard can affect the economy of your country. Mean that we have to careful and we have to maintain all techniques in order to live in the best conditions, maintaining, of course, the economy in our country. Okay. Sorry. So when we have to talk about the coast, so let me show you one example. Firstly, when we are talking about to have a global view, this is what I want to say. This is the eastern part of India. And when we are talking about some questions related to the coastal dynamics, even you have to look about details like this coast. We need to understand what happened at the large scales, including the north parts, the south parts, and to look about all the factors that factors can affect the littoral zone. So we have to talk at the meta scale to go to mega scale, and slowly to go maybe to the micro scales. So from the shoreline from a large country like India, we have to go to maybe to try to understand the dynamics and to model the currents, and we will look about ripple marks. So sometime if we have a patience, maybe you are a sedimentologist and you like to model or to discuss about sandbars and ripple marks, but we have to try to understand what could be the origin of the ripple marks and what could be the origin of the sediment that we can find here. Anyway, the ideas that we have here, we are looking about different scales, and to build a coast or to build a deltas is not the same time. And then when we want to preserve a coast or a shoreline, we need to recall to people that when you are talking of ripple marks, you need maybe 1 hour or few seconds in order to build it. But when we are talking about deltas, we need many years and sometimes 1,000 years, so or more. So be careful with that, and mostly we don't have to forget that. We have to put in our mind all the time the space, and the time, and to define at the beginning when we are talking where are the subject that I want to understand in this space, and what about the time that I want to discuss as well. Time and scale, very important. Example of South Asia: structural context, sedimentary basin, topography, seismicity, main active fault, etc. Mostly when I'm talking to my students, I say in France, they don't realize that we don't have many geohazards. It's totally opposite with what we can record in Asia. And when you are Indonesian, of course, you are always maybe thinking about georisk or geohazard. So when you are talking with some people from Europe, they don't know that, or they don't realize that can happen anytime, anywhere in our country. So the philosophy we need as well as teacher to recall to people that if we need geologists or if we need engineer from geological department, we need to share all the experience from everywhere in order to try to constrain, to understand all the controlling factors affecting the coast, for example. About the coast that we have in Southeast Asia, the structural context, the seismicity and the tectonics are very complex. And you are located in the place that is moving very quickly and very rapidly. So this is a sketch showing the Java Trench, and you can recognize the place where you are living. We will go for more details later on. So let me share with you some slides showing when the India continent was moving toward Southeast Asia in the northern part, and between Asia and in this place, if you know, we had oceans. Tethys Oceans was there. Sorry for was there. So it was a place when we have recorded some sediment, of course, marine sediments, currents, etc. And India was moving, and before to collide, we can observe new processes, marine processes around India on the left or on the right side. And these collisions is responsible of most of the type of coast that we have in Southeast Asia, with creations of different basins, and creations of different mountain and relief. And by today, we have these geographical configurations showing that in Southeast Asia, including full Indonesia, you are located in a place still seismically very active, somewhere very dangerous, but we can have some tsunami, some earthquakes, and can affect whole the populations living nearby the coast. Anyway, mostly and all the time we have to record to people where we are living, and in the context where we are living, the history that we are looking for to try to understand all the controlling factors, specifically in Southeast Asia, are very, very, very recent at the geological scale, so, or geological time, if you prefer. So when I am thinking about the coastal management in Java, so you have an opposite view from the south if you compare with the north. So look like Java North is protected because less earthquakes can be affect the northern coast by comparisons with what we have in Java in the southern part of Java. Of course, everybody remember what happened in 2004 in Aceh area with the big tsunami affected all the populations. Anyway, when we are looking for about the coastal management, coastal dynamics, even in France, I have to show to my students that the coast, the type of coast that we have here depend about the history, the geological history, the motions of the tectonic plates. Then when we have this context, of course, in Southeast Asia, we have a lot, as you know, sedimentary basin, very complex as well, a lot, so many basin created recently after the collisions between India and Asia. Most of the basin are very recent. That's why oil and gas that we have in these regions are very pure if you compare with oil and gas that we have in USA, for example. So a lot of basin around Indonesia, very complex. And one specific thing that we have here is the Sundaland place or space. So this part is very shallow marine place that we have between Java and Borneo Island, between Sumatra and Malaysia Peninsula, etc. Very shallow zone, and a very shallow zone in Java Sea. It's around 50-meter depth, something like that. But anytime, everywhere, you have a lot of earthquakes in this area. So most of the earthquakes that we have in Java can affect my country. So if I am Indonesian, I can imagine that even I'm living in Semarang, I know that possibly the earthquakes can affect the basement and maybe lead some motions, vertical motions. This is what we have to do with UNDIP, and this is one of the projects that we want to develop with Najib and most of his colleagues. So to try to see if the vertical motions that we can observe in Semarang, that the cause should be and are very complex, but can be explained as well with all the earthquakes that we have over everywhere. And you have as well a lot of volcanoes. So from Europe, from a French guy like me, you cannot avoid that. So I am very, I will say, impressed with this context. And earthquakes and volcanoes can affect suddenly and change suddenly your area, your landscape. So by today, we can follow with GPS, with satellite image, with seismic monitors, all the earthquakes, and help scientists and help as well politics to have a better understanding about all the causes of geohazard that we have in this area. So this slide summarizes as well what I want to share. When we want to have a better understanding about the coastal evolutions, even in this context in Southeast Asia, we need to look with details about earthquakes and all those subtle vertical motions that they can affect, modify the basement, the soil where we are living, because we know that with the vertical motions we can have some I will say we can change the accommodation space, and we can change as well the compactions of the sediment, and we can maybe see some displacement. Very subtle, maybe in Semarang, very subtle, maybe in Java Island, but I think so that we have to continue to record, as you do in Indonesia, all the earthquakes and the consequences that they can have in order to react or re-affect some faults. And when you are, I don't know, president of Indonesia or politics, or even you are scientist or students and very young, so your country is it's a big country, the largest archipelago of the world. So, and when we have to try to work on this place, we have probably to start very slowly. So this is my view. And then when I see that, I say, oh my God, so you have so many places where we have to work. France is very small. If I compare with that, very small. It's France country, the superficie, it's around Borneo Island, you know, it's less than Borneo Island. So, and independently about the total of people living in Indonesia, Indonesia is the second country about the length of coastline. Then, with all the questions that you have related to climate change or geohazard, of course, that it's probably very complex for politics or all the council or all the department to have a global view and to try to help or to adapt or to provide some tools in order to discuss or to explain to the people what they have to do, etc. But it's a big challenge, and I think that the challenge has to be due, or don't you have to be optimistic with the futures. I'm focused more and more to Java Island. So when we focus, of course, we can see as well the complexity. So slowly and slowly, we are starting before the collisions with India 30 million years ago, and now this is at the present day. The context in Java. What can I say? Java Island, it's a narrow island, and it's around. I have a screen, a slide later on to show that, but very narrow from the north to the south, 1,000 kilometer length, width, if you prefer, located between India Ocean and Java. A lot of volcanoes. So the backbone of Java, it's volcanoes. Most of the volcanoes are, for me, very recent. And the area, where is my pencil? Okay. So in the, oh, sorry. Okay. Okay, sorry. In the north part over there, in the brown colors, many people are living, and most of this part of Java is dominated by sediment from the transportations and erosions from the volcano area. So even the coast here in Java is very, very recent. So most of the people are living in a place that the basement is mostly dominated by sediment. It's a coastal plain. Very small deltas that we can see in this bay between Jeparan and Seriban. Okay, a lot of small deltas. Sediment supply come from the volcanoes that we have over there. And if I compare with the southern parts, in this zone, a lot of earthquakes. The coast is not really muddy coast that we have in the northern part. Some bay, it looks like the same bay that we have over there. So we have some similitudes. Similarities that we have there can be seen here. And one thing that we have as well, we have fault, big fault. Some faults are very old, and we have some gravity faults as well, explaining the shape of the type of coast that we have over there. Let's see, when I take time to try to see the type of shoreline that are over there, probably this fault, we have probably another one parallel to this zone. And we have fault over there. So this bay, this large bay, it's controlled by fault. If I go to Jakarta, it's the same thing. Mostly you can observe some regular shoreline with very straightforward, very straight coast. And it looks like affected or with small deltas. But anyway, if I have to summarize, Java is a very recent island, and the coast is in the northern part dominated by deltas, and as well affected by faults. Maybe most of the faults are not really active, but sometimes probably active. And the backbone of Java is dominated by volcanoes. And most of them are active, few of them are very dangerous, and people are living on this place. So it's very interesting to see how we can manage all the factors in this context. Then all the time, you need to look about that, to take care about all the factors. And one of the challenge in Java Island is you have probably all the factors, and most of the factors are active. I'm thinking about tectonics, active, magmatism, active. It's not the case in France, for example. You are talking about climate change, okay, everywhere by today. What about the wave? You have a lot of wave with the monsoon, a lot of currents. So your country and around Java, if you are thinking about what are controlling the evolutions of my shoreline, all the factors have to be followed in order to help scientists, engineers to try to propose some infrastructures or ideas in order to protect the area. And again, just retrace your geological map. Franto gave me some map, and then I was retracing a few of them. You can see that most of the lithology that we have in Java is dominated by volcanoes, of course, and quaternary deposits are mostly everywhere. And we have, of course, some tertiary deposit showing that Java, in terms of geological fact, are very, very recent. And if you take time to see all the faults that we have in these regions, so you can see we have a continuity of faults from inland to where Java Sea. So it's really very complex, and you have many lithology as well. So when we are talking about preservations of the shoreline, or we have to see as well which type of sediment we have in this area. We will discuss later on about the sedimentary facies. Okay, so another slide showing all the volcanoes that we have in Java. So it's very beautiful when you are looking about the digital model showing as well, I will say, the vulnerability of this area. If you are in the middle part, everywhere here, you can reach maybe 3,500 meters above the mean sea level for the Merapi, for example, volcanoes. But when you are living nearby Semarang, it's like you are in the sea. So the coastal plain, it's very flat and very close with the mean sea level. And with this context that we have the change of the sea level, and the sea level is rising everywhere. So Java is an area that can be affected everywhere, and specifically in the northern part, because this coast is very recent, composed by modern deltas, and most of the sediment are not really compacted, and the sediment supply still active, but human populations are evolving and developing many infrastructures. And I will say the wild has not the same time scale that human activities. So we have probably, but it's not only in Indonesia, we have probably contradictions between human impacts and what we would like to do at the surface of this beautiful planet. Anyway, you have to just summarize volcanoes and very narrow coastal plain. Then probably very brittle when we are talking about climate change. Anyway, in Indonesia as well, in this context, you have a lot of ecosystem and diverse coastal ecosystem that you have to take care as well. You have carbonate deposit, you have a lot of highland with corals, you have mangrove, you have dune, you have sand beach, etc. And you have muddy coast, you have deltas. So most of the ecosystem that we have here can be nearby the coast or in the Java Sea, or so we will show and we will discuss about all this ecosystem as well later on. And again, when you have to work about coastal management and the geohazard, so you have to monitor some factors and you have to adapt and to try to follow if any events can affect, for example, the industry offshore that we can have. We have to take care about mud volcanoes maybe, and you have an example in Java nearby Surabaya. We have to take care about tsunami. So people from Indonesia, you know about that. And you are working and to develop knowledge in order to have a better understanding about the landslide that we can observe in the offshore part, for example. This is a seismic line showing over there some sedimentary layers. And you see here, it's like a huge and very irregular sedimentary body. This is a landslide after earthquakes that we can observe over there, that we call that debris flow. And this debris flow can be caused by earthquakes and sometimes can cut cable that we have between all the islands that you have in Indonesia. In parallel, when we are talking about coastal erosions, in this zone, you don't have a lot of people living at the back of the coast, so we can maybe protect, but anyway, the vulnerability is very low. But independently about that, you see here in Mediterranean Sea, we are putting some sea wall, perpendicular to the sea in order to stop the migrations of the sediment, in order to maintain a quantity of sediment. And if you have a lot of sediment along the coast, like sand, this volume of sediment can be a buffer allowing to absorb all the energy from the sea. That's why we have to take care about all the sediment come from the mountain in order to have a large buffer to protect human activities. And one of the error from human, it's to think that maybe sediment supply is not really important, or we have to look with details about the sediment that we can maybe take from for the building of houses, etc., or infrastructures. And you know that in Indonesia and even in the past in Europe, we were taking sand in the rivers, and we affect the budget of the sediment along the coast. And it's another question that we have to as well to try to understand. But to look about the coast, it's not sufficient. We have to look about the sound wave and where are the budget along the coast, but as well to try to look about the budget that we have in the Java Sea, for example. And you have to monitor and you have to continue with your university or with your public institute, like the MGI at Bandung, Marine Geological Institute, to collect data and to have a better knowledge that of all the architecture of sediment or sedimentary facies that we have in front of the zone that we would like to protect. So geoscientists are looking for so many things, and mostly it's because you are human, of course, and you want a social life. You want to maintain this social life for the futures. Because you want to consume, to be happy, to have a happy life. And in parallel, around the world, by today, you have many questions that we would like to solve, many questions that we would like to resolve in order to help politics to maintain this economical point. But it's not very easy all the time. Then engineer from geological department at UNDIP want to work and to form the next generations to have a better understanding about controlling factors, the time and the space, at the long term, at the short term, and we have to monitor observations, and we have to build a database. So we need not only geologist or engineer, we need as well engineer from computer science. So everywhere now, and this is what we are trying to do with you in UDIP, with geological department, the COREM with Mohamed Helmi, Hanid, etc. We need to have a multidisciplinary approaches and to share all the techniques in order to optimize answers for all the questions that we have. And one of the things that I believe very seriously in order to share with all the publics is to build a database. Let me share with you a sketch that I drew with my colleagues for books with Ramkumar from India. It's a very good friend. He's working as professor, full professor in India. So this sketch or these figures, you need to know these figures. You can use it for your teaching. You can use it, and you can try to retrace it, and you can do yourself a figure like that. This is one of the figures that I share with my students. So from the mountain, could be Himalayas or could be Merapi volcanoes. And if I use it for Java, these figures can work as well. So we have on the left the mountain. In Java, you don't have snow, but maybe later on, we don't know. You have high relief. The altitude is around 3,000, almost 4,000 meters above the mean sea level. And you are living the context where we have some uplift, where is moving up sometime, the basement, sometimes is moving down. And from your rivers, you are going toward the coast and you are building some deltas. And the deltas are also affected probably with some faults. And in Semarang, if you remember, I show you that you have some fault can affect and maybe participate to the subsidence of this area. And the deltas where you are living, most of the people in Java are, I just told you a few minutes back, are very recent and depend mostly of sediment supply come from the mountain, come from the volcanoes. And the distance between the volcanoes and the coast are very short. It's very rapid to record sediment from Merapi to the coast or from another volcanoes nearby Semarang to the coast. And then you need to care about this area, this place that we know and that we call, alluvial plain. So from the alluvial plain to the coastal plain, there is a balance. There is a link, I will say a genetical link. And my transportations of sediment don't stop along the coast, because with the controlling factors, with the wave, with the tide, even the tidal range is very small in your country. During the monsoon period, you have some very strong period where the factors can affect and can redistribute all the sediment that we are putting over there. And we can rework sediment and can go in the deeper part. In the offshore zone, you have some island with corals, can be as well related to some tectonics or not. But anyway, corals can build and can be adapt their ecosystem, trying to follow the sea level rising, but can be as well very affected by the sediment supply. Anyway, after that, when you are going after the shelf break, you have some turbidites. That turbidites that we can record in Java is located on the east part, so going to Papua New Guinea, for example. Okay, so if I summarize, you have the high relief in Java, so you transport sediment from the volcanoes going toward the coast, and most of the deltas are built with this type of minerals from the volcanoes, and my deltas are very recent, can be affected with some gravity force, with the compactions can be related to that, and can be accelerated with the number of earthquakes, etc. And you can see the relations between this area toward the turbidite that we have here. So some part can be subsided, some part can be uplifted, or can be uplifted there and subside over there. In my mind as well, every days, if you are not geologist, maybe you don't think about that, but maybe few of you would like to work in the energy company, or you want to be engineer for marine aggregates, you want to work in relations with water resource, CO2 injections, etc. So you have so many resources that we are using, and we have as well so many jobs that we need for the futures. In order to maintain an economy and the peace in higher country, you need to take care about all the resources that people want to develop. So maybe we are looking about offshore energy when oil and gas can be not sufficient or for all the consumptions that we need everywhere on the world. And in parallel, we have to take care about landslide, coastal erosions, earthquakes, tsunami, etc. To do that, so we can play with many tools like satellite, we can use some acoustic imagery, we can follow and collect some sediment in our rivers in order to see the quality of the sediment, which type of sediment we have. We can as well discuss about the pollutions and take care about the quality of the water. And we need as well to monitor and to use at least meteorological data in order to predict maybe landslide or geohazard. So many things to try to follow in these topics. At the global view as well, because we will talk about marine sedimentations, we have to have some information or knowledge about marine sedimentations. 2 points, source to sink, dynamics, and the biogeochemical cycles. And I will share with you ocean sedimentary map, and we will finish with the geological sedimentary map in Java Sea. So, you know, marine sediment and any deposit of insoluble materials, primarily rocks and soil particles transported from land areas to the oceans by wind, ice, and rivers, and the remnant of marine organisms, product of submarine volcanism, chemical precipitates from sea waters, and materials from outer space, like meteorites that accumulate on the seafloor. So this is your area, all the sediment, marine sediment that we can observe around Java Sea. I will come back later on with this map and try to summarize what can I see like French people to try to understand which type of sediment we have and why it's like that. But again, when we want to understand the evolutions about my zone, or to have a better knowledge about marine depositions, etc., you have to follow all the particles, where they come from, where they're going, how many times they need to come from the volcanoes to the sea. We have to estimate as well how many million of sediment supply are arriving along the coast, which type of solute are transported as well, and if sometime we affect by presence of a dam along the coast, or because you are collecting some sand for building, but you have to say, you have to use this data. This is human impact, in order to as well explain that when I am taking sediment every year, for example, if I stop the continuity of the sediment transport, of course I affect my coastal zone. And by today, many topics as well is to try to estimate the pollutions from the industry, etc. So everybody everywhere now, independently if you come from Europe, USA, South America, people want a life with less and less pollute. So it's not easy, because we need time as well to change that. But anyway, we have to be clear and to share about all topics people are talking, by the way. Okay, so again, before to look about sediment in Asia, I need to have a global overview about which type of sediment we have on the sea. So this is a very, it's a map from a book that we have over there. So most of the sediment have different sources, heterogeneous, biogeneous, hydrogenous, volcanic, and few cosmogeneous. It's a lot. It's not a lot, but anyway, for human, we are more interested about heterogeneous deposit along the coast that we have. Let me share with you another figures that I have published as well, that you can use it, and you can just recall the source over there. So again, for students, this is what I share with my students. Firstly, I trace topography profile from the mountain toward the abyssal plain. So the continental zone is on the left, the marine zone on the right, and in the middle you have the transitional place. And most of the questions that we have by today is somewhere here. But in this zone, you need to know what happened before in the upstream part or in the downstream part. And we need to know about the budget, sedimentary budget, the thickness of the sedimentary deposit that we have in the coastal plain, and which type of sediment. And I like these figures as well, because summarize what we need to know. And when we are looking about the littoral zone, I made a choice to say the littoral zone can be dominated by sand. But in your country, in nearby Semarang, is mostly a mangrove system in the coastal plain, passing to a muddy coast. Anyway, if your coast is dominated by mud or sand, you have to use all the factors like wave energy, what about the wind, what about the salinity, what about the currents, what about the oxygen level. All the factors can as well affect and explain what happened along this coast. Let's go again at a global view. If I need to discuss about the thickness of sediment, I have to care about the thickness of sediment nearby my area. And I can see that mostly in Southeast Asia, you have a lot of sediment. we have a lot of sediment, but at the same time, we know that most of the sediment that we have on the oceans will not go to along the coast like that. In order to increase, for example, sedimentary budget along the coast, is not by this way that we have to look. Maybe if I was not very clear, I can come back and to discuss during the questions sessions about that. But again, when I have to start a project with my colleagues in Semarang, I was looking about the sedimentations that we have in this place. And most of the deposit that we have in Java Sea, it's very fine, it's muddy. You have a lot of mud in Java. And if we have a lot of mud in Java, it's related to the first slides that I was sharing with you about the geological context, because this area, it's a sheltery zone, very shallow zone, sheltery, and we are not surprised to see only mud. And we have as well a lot of carbonate deposit. And again, why we have carbonate, you know that it's related to the latitude, because you are in a context where the climates can allow to have a lot of coral reef, and you can increase the productivity of carbonate in this area. So mostly, if I have to look about details nearby Semarang, I know that most of the sediment that we have here, at least at the seafloor, it's dominated by mud and carbonate. Okay, thank you so much for this first chapter. Before to start the next one, I would like to take 2 minutes and maybe to see if ready, if we can maybe have some questions before to start the second one. What do you think, ready? En Egypt.
Okay, thank you very much, David. Okay, everyone, for all participants, the first session for question and answer is open. If you have any question, please maybe raise your hand or just open your mic and ask your question.
Can I take 1 minute, ready?
Yes.
I need. Okay, I will come back. I take 1 minute. If they can prepare the questions, and I will come back.
Okay. Okay, everyone. Do you have any questions to ask? We will wait until David comes back.
Halo, permisi. Can I use bahasa?
Bisa, nanti saya translate aja, nggak apa-apa.
Oke, Pak. Terima kasih. Izin bertanya. Jadi kan dijelaskan bahwa di Laut Jawa itu tinggi tengah karena Laut Jawa itu lautnya cenderung tenang lalu dangkal, itu kan banyak kandungan lumpur. Nah, sedangkan beberapa waktu lalu itu ada berita tentang semburan gas dan lumpur di daerah Brebes kalau nggak salah. Apakah dari kandungan lumpur, letusan lumpur tersebut berasal dari sedimen yang di Laut Jawa? Bagaimana mekanismenya bisa terjadi semburan lumpur tersebut? Terima kasih.
Okay, David, we have a question here, but he asked in Bahasa Indonesia. He stated that Java Sea is quite shallow and may contain lots of mud. And a few moments ago in Central Java, we have mud volcano explosion. And he asked that, is it possible that the mud volcano explosion comes, the source of the mud is from the Java Sea?
Okay, ready. Let me, if you can repeat the first part. I mean, I understood that you said if the mud come from the Java Sea, from and about which place? Could you just repeat the place?
In the Central Java, somewhere is in the east of Semarang.
Okay. Okay. So, I can share. Do you see my screen? I don't know. Do you see that?
Yes, you can see
okay.
The screen.
So you mean that the question is about the mud that we have somewhere here?
Yeah.
Okay. So the mud that we have along this coast, for example, in these nearby these deltas, or can I focus about this place, for example? Is it correct? Is it the questions? If I want to be sure that I'm taking one example that it's related to the questions.
Imsak, posisinya di sebelah mana? Wait for a minute, David. So I will ask the position.
I don't know the current position, but in the city of the name Brebes.
Brebes.
Sorry, Imsak.
It's near with
mud volcano.
Imsak is near with coastal.
It's meant Blora.
It's Blora. Yes, it's in the east of Semarang. It's around 100 kilometers east of Semarang.
So no, I just want to be sure that I understood the questions. Is it these questions? You want to know about the origin of the mud along the coast of Java Island?
Yes.
Okay. Okay. So, firstly, when we are talking about mud, we have to check if it's organic, 100%, 100% minerals, or a mixed. Firstly, I'm thinking about clay, mostly. If you can take the mud, check if it's not only from organism. Sometimes, you know, in France, where I'm living, for example, the mud, it's mostly from the organism like oyster, mussel, and it's not all the pellets or all the that they can product. In parallel, mud can be dominated by clay. So if I look about this zone that it's a muddy zone And we can observe with the wave process or the currents, you know, we call that some plume. So we have some difference of colors on the sea. The clay that we have over there can be historically organic and minerals. Secondly, the clay that I can observe along the coast come from the erosions of the deltas. The clay can come from as well. Donc, thereby you have some erosions, you can rework and create this plume. Mud can come from the rivers. And it's true, some clay, because Java Sea is very shallow, if wave processes and tidal currents are strong, you can have some clay coming from Java Sea. In order to check that, I'm not specialist about that. You have probably to look about microfossil or geochemical index indicators in order to know if a few of them come from the Java Sea. But clearly, when I see that, when I can observe this zone, most of the clay look like come from the erosions of the coast and from the rivers. This is what I feel. Okay, if I take these deltas, for example, you can see the deltas over there. So the clay that we have here can come from the land. But if I look at this scale, for example, or at this scale, maybe you have some transportations of sediment from the west part to the east part with the longshore drift. Then if I summarize, you are right when you say clay can come from the Java Sea because it's a very shallow zone. But along the coast, when I observe the satellite image, I can feel that with the wave activities and the tidal currents along the most of my deltas, I can erode, rework the fine particles and transport the fine particles. And few of my fine particles, clays, can come from the rivers after the big precipitations that we can observe in your country. Is it sufficient, or do you want more details?
Imsak, is it sufficient, or you want to ask more questions?
Enough for your answer.
David, should we open another question? Accept another question,
Yeah,
or
of
you want
course.
to continue?
Yeah,
Okay, for
another questions, I think.
Okay.
Because can help me for the next talk.
Yeah. Okay, are there any more questions you want to ask everybody, for all participants? Question and answer session is still open. Okay, Mbak Anis Kurniasi, please.
Okay, thank you. Ready? Can you hear my voice clearly?
Yeah, I can hear.
Okay, first of all, I would like to say hi to David.
Hi.
My name is Anis, and I'm actually also a staff from Department of Geological Engineering, and I'm in partner with Rodi in teaching stratigraphy. And previously, you already mentioned about the volcanic activity, especially in Java. And you also mentioned that besides we have a wide range of volcanic, we also have a very narrow coastal plain. It means that we have potential to have abundant sediment supply, while we have a very wide sediment transport space. So it means that it will be threat, I think, for the people who live in the coastal area, since it might be possible that it will be dangerous to have an overload sediment supply. So how do you think we can solve this problem, since most of the people in Indonesia living in a coastal area? And what kind of infrastructure that we can build, and maybe you can give a recommendation or solution, and that's it.
Thank you so much for your questions. I think really it's a very big challenge that we have, not only in Java, everywhere. I will start. It's very complex, I think. We need to continue to educate people, firstly. So we have a role to play by today, even to educate politics. I mean, and this is what of the role that we have to have in our university, in your university, in my university, and together to work using example from France, from USA, from Japan, as you are doing to invite Magali and colleagues from Japan or Indonesia. Because everywhere, you know, we have the same questions and we don't know what we have to do. What we know that even people are rich or poor, it's very complex for people to say we have to leave the zone. I mean that people have to accept the situations or the new situations. But I will say, if you have a house, you are not maybe geologist and you are living there in Java and you have a happy life, and suddenly people are saying, oh, be careful because you are living in a place that could be very affected by a tsunami or maybe flooding, that, like, as you are saying, seeing, I'm watching, I think every day is in Java, people can say, okay, but I want to stay. So what we have to do, I think we have to continue to educate people, and more people will listen, will learn about what is the deltas, how deltas can evolve, why my deltas is moving like that, etc. People will understand that we have to go back or to live maybe in the place that it's less dangerous in the futures. For that, we need time. Even in France, we have same questions, and people, for the moment, they are realizing that maybe some places are a little bit dangerous. About your questions concerning the sedimentary budget, it's really important that we to explain that we have to care about this sedimentary budget, even for the quality of the water and the preservation of our ecosystem. When I say that, I am thinking about all the natural resource that we are using. I'm thinking about fish that you like in Indonesia, as everywhere, because we modify so rapidly our ecosystem, and we are changing ecosystem, and we are affected all the zone. So it's a big challenge. I don't have one solution, but I consider that locally, if we start to work, I don't know if you can see me or you can hear me, I don't know, but okay. If you can locally continue to explain to the people what they have to do. Slowly and slowly in our country, you can maybe have better answer in the futures. But I think we need maybe again 50 years at minimum, or 100 years to explain that. You cannot change that rapidly or quickly. The visions that we have about the littoral zone is so complex, and so many people are living there. Even when this is with my introduction, I start with that. It's a lot. So politics has to explain, to take care about that, and to educate people, and scientists, engineer has to continue to work. I consider, and I will finish with that, that build a database, collect this database for the future generations in order to help people to have at least some photos or videos. And I believe a lot about GIS, Geological Information System, in order to show what was the evolutions last 10 years and what could be the next evolutions 10 years in the future. I believe that with that people can change. I don't want to do politics. I mean, show the data and don't provoke people. Continue to collect and to monitor the zone, even in Semarang. You cannot change Semarang in 10 minutes. Then we have to try to do our best like that. I don't know if it's enough as answer. It's not really a nice answer as well, so because it's very complex. We need time, and we need to continue to educate people, and I'm so sure that we don't have all the elements in order to understand what we are.
Okay, thank you so much, David. But actually, I already have another question. If it's okay, ready? Do I still have
Yes,
time?
please. Yes, please continue.
Yeah, it's actually about another problem, because we're not just facing the problem from the continental flooding, but we're also facing here, especially in Semarang, the marine flooding. The scientists say that it's related to the sediment compaction and also the subsidence and sea level rise and everything. But the rumor is like the government want to build the marine like coastal barrier so that they can block the flooding from the marine. But the problem is that if the flooding is because of the sediment compaction, don't you think that it will be fasten the compaction, or is it the right solution? What do you think about it?
So, as you know now, you know that the rate of the compactions is not the same everywhere. That's why we need to continue to work with you and your skills and better knowledge about what happened in Semarang. That's why I will say again, I believe about your GIS database in order to show what was the evolutions and what you have to improve in our system. It's how many, what is the volume of sediment coming in the coastal plain, and maybe to select a zone where you will say with your colleagues in your university, next 10 years, we will follow this place in order to see and to show later on how the compaction is evolving. You know, I don't believe that it's good ideas to put a barrier in front of the sea. It's like we don't want to see the futures, and then I consider that we can play with the natures and I don't think that the good way is to continue to try that we can go even in the Java Sea, because it's very shallow. Maybe you can build something. I will say again, maybe I'm mistaken, but let me know how you can build something in northern part of Java where the deltas are still young. So even in Mississippi deltas, we observe the same thing. Then, and these deltas is older than the deltas that we have in Java. We have to follow with maybe a better way sediment supply from the land, and to continue to observe this folding. I can feel that it's very sad to see that, and to continue your project that you have already started. I was looking about some photos, then I want to see, but I want to share with you my screen. This photo, okay, that Elmi gave me. I remember this one. I think it's good concept to try to. I don't know if you can see the slide, but build with nature. This is one of the ideas that you have developed in Semarang. You have to try to trap the sediment, probably to trap. And I saw that it is not easy. I came here and I saw that these structures. Try to continue to do that. And don't believe that we can go back maybe with the last shoreline in 2003, but at least protect the mangrove ecosystem, because it's a very nice buffer.
Thank you very much, David, for your answer. It means a lot to me. Thank you.
Thank you, Anis.
Thank you, Mbak Anis. Okay, David, shall we continue?
Okay, I can
Okay.
continue.
Yeah.
Okay, then I will open the next PowerPoint. Okay, this one. The next one, chapter 2. So chapter 2. Then I will stop at 10:30. On next sessions, we will start with the questions. What do you think, Randy?
I'm sorry, can you repeat your question?
No, I will say I will start with the chapter 2 now.
Okay, yes, please.
Okay,
It's
I
okay.
have
You still
30
have time.
minutes.
Yeah,
Okay,
you
we
still
have
have
how
30
many
minutes.
Okay, 30 minutes. Then let me know if I have to stop before 30 minutes or not. Maybe I talk during 20 minutes and I will open with the questions.
Yeah, after 30 minutes, we can start another discussion session.
Oh, okay, okay,
Yeah.
thank you. So, okay. So the chapter 2, it's about clastic coast and shoreline processes. So we will discuss about controlling factors, explaining the coastal evolutions. I propose to start with definitions of the shoreline. A shoreline is a line of demarcations between lake, sea, or lagoonal waters and an exposed beaches. I took these definitions in this book, in Reading and Collison from Blackway Science. So let me go. Alors, a shoreline, it's a brittle, it's a line, so can move very quickly or very rapidly or slowly, we will see. And we will talk, I will talk only about shoreline along the sea. Top 10 country in terms of coastline length. So just to recall that Indonesia is the second one after Canada. then it's a big challenge, because by today, with all the questions that we have related to the climate change, Indonesia need to monitor and to have maybe a guide in order to see all the evolutions in this context, with all the activities that we can record. So later on, I don't know, but what I propose, I need to define type of course that we can observe around the world. So this is a plan view of transgressive and regressive progressional coast that we can observe. Sometimes it's tide dominated, sometimes it's wave dominated. I will explain later on all these things. So let me start with what we have. Again, I have to change that. Sorry. Okay. So if I try to use from Boyd et al. 1992, sometimes the zone, like in northern part of Java, it's a tidal flat zone. Can be cut by rivers, and we can observe estuary, or in your case, deltas. And laterally, we can have sometimes some strand plane deposit with mostly sandy place dominated by sand, or we can have as well some lagoon, and the lagoon in some context can be in connections with the oceans by some inlet, very narrow inlet like here or here, and a barrier can play the role of a buffer. So you have on the left when the tide is dominated, and on the right when wave is dominated. So to summarize, the consequences of the tidal power is to how I can say, the energy that the tidal currents can provide will be expressed along the coast by fine sediment, and the sediment will be preserved in a large, very large zone. And the zone is very flat as well, and is one of the characteristics of a tidal area. By oppositions, when you have wave hydrodynamism and when the wave is dominated, you concentrate particles with the grain size is bigger than silt. Mostly you have sand, sometimes you can have gravel as well, and you concentrate the sand along the coast, building some beaches or barrier, or maybe a strand plate. And in the middle part, you can have some place around the world, tided dominated or wave dominated, and you can have a mix. In your case in Java, mostly it's a tidal, it looks like tidal dominated because it's very muddy. You have a tidal zone specifically when you are looking about your coastal plain with the mangrove system. This is the case. But wave can be strong sometimes during the monsoon period. But as one of your students said, where come from the mud along the coast? Mud can come from Java Sea, and you don't have a lot of sand in Java Sea, sorry, mean that how you can build a coast with sand if you don't have sun from the offshore. And most of the sediment come from volcanoes supply sediment, yes, but the particles that they supply along the coast are dominated with minerals, and the minerals as pyroxene, olivine, amphibole, it's ferromagnesian silicate, is not quartz particles. Very quickly, most of those minerals come from the volcanoes, cannot be, very strong sun, because with the withering, you can wither all the particles, and most of the particles can disappear as well. This is one of the particularities about Java. So you don't have a lot of granites or gneiss or metamorphic rocks with quartz particles in order to provide sun along the coast. Then again, when you are talking about siliclastic coastline, in your case, siliclastic, yes, but which type of minerals? And we don't have a lot of quartz because most of the catchment area and the basin drainage are dominated with volcanic rocks. And volcanic rocks didn't provide minerals like quartz particles. It's a difference between what we have in Java and what we can observe in Europe, for example. Anyway, it's important. And with this type of coast, tide-dominated or wave-dominated, we have all the depositional system that we can record. Sometimes it's sandy, sometimes it's muddy, and you can build shoreline, linear shoreline, strand plain, barrier island, chenier, tidal flat, and I will provide some document about that in order to show all this type of shoreline later on. Now, type of coastline human like to classify. You can classify your coastline with the tidal range, microtidal, mesotidal, macrotidal. So in your case is microtidal in Java. And you can see there, beaches and barrier need are best developed, in micro and mesotidal area. Estuary, tidal flat, and ridge are best developed in macrotidal regions. So in your case is microtidal, so you can have beaches and barrier. But in this place, in the northern part of Java, it's mostly dominated by tidal flat and mangrove because of the geology, because of you are in the sheltery zone, and you don't have big rivers transported sand with quartz particles. Probably it's one of the reasons that you don't have this specificity in Java. Then again, if you want to explain that to politics or to the society and to the people, just to compare, we have to compare. Why we have more sand in Malaysia, for example? I think I'm talking about Terengganu zone, because in this case, some rivers supply sediment from a zone that we have granite. The backbone of peninsular Malaysia, like as Belitung Island, we have granite. And the sediment along the coast is different. So after this rapid, I will do a rapid introduction. We will talk about sediment supply, sediment delivery to the basin. So a lot of repetitions that we will propose. We will talk about dissipative and reflective beaches, all the things that maybe you know a lot probably about that. I just want to share with you a few of the slides. So shoreline morphology reflects the interactions between supply of sediment and basinal reworking process. So you know that now, and you can use some slide that I already gave to you. the principal processes is fair with the wave and tide. And of course, sometimes your shoreline can be affected by storm or tsunami. And you can edit, modify very quickly the shoreline, like the modifications we got after the tsunami in Aceh zone. Tide affects shoreline. In Java, it's not very easy to see the high tide, low tide, but when the coastline plane is very flat, you can observe some change. I will show you some examples from France. Wave give a range of currents, rip currents, long-term currents, onshore currents. This is what we have as well in Java. And storm can interrupt day-by-day processes. It's important that to look about storms, but in Java, for example, flooding, it's really important as well, and mostly affect the country. I will not say every days, but it looks like every days. Let me share with you one type of course that we have nearby Van, where I'm living. So this is Ethel City, a small city. So you see that people are living just at the back of the coastal plain. This zone is very flat, but we have a law in France that now, since 1990, you cannot build a house nearby the coast. So it's totally forbidden now, hopefully. But we have some case that we have houses, and some houses can be affected now by the storm or flooding after high tide with some period during the winter zone, winter period, for example. So the coast here is, you see, dominated by sun. At the back, we have marsh. We can observe over there a very small lagoon. The coast can pass and can be a rocky zone, but very flat zone. And the type of coast depends about the degree and power of wave or tidal activities. In this case, you can feel probably the wave, they are coming parallel to the zone. And with the wave energy, you can push the sun along the coast, and you build at the back a buffer with a dune, protected this area. In the inlet here, you can have very strong currents, very dangerous place here. This looks like very quiet place. It's not very quiet, very dangerous. You have a lot of currents over there. Grain size, it's cross, because most of the place in front of over there, it's sandy zone. Most of the sediment come from the oceans. It's a very shallow place. And of course, we can have some questions with the relative sea level change. In this case, if the sea level is rising, what could be later on the shape of the shoreline in this zone? If the sea level is rising, you can reach very quickly and to be at the border of the city. And we will have the same questions that you have in Java. Okay, then in order to summarize, the next slide is to show all the controlling factors that I have to discuss: the wind, the swell, the tidal range and tidal currents, the wave approaches, the longshore drift, the rocky coast. And in this area, the sediment that I have over there depend about all the factors that I have to monitor in order to show eventually the evolutions of the shoreline. Then to summarize, sediment is supplied to the oceans from the land, both large continental regions. Okay, this is the theory. But in Brittany, where I'm living, mostly the sediment that I have along the coast didn't come from the land. because we have some rivers, but in the drainage basin, we don't have, the relief in order to allow to have sediment from the land. Most of the sediment that we have in Brittany, in Europe, where I'm living, is old heritage related to the last inundations, the last marine inundations. Then in Brittany, for example, we have to take care about this sediment, the sedimentary budget, because most of the rivers didn't transport sediment from the mountain. We don't have mountain. We don't have volcanoes. Then my sedimentary budget sometimes can be only heritage, and I'm not putting or adding some particles. Then we have to care. When we are thinking about Ganges deltas or Indus deltas or Mahakam deltas, it's muddy zone as well, or Baram deltas. Okay, we transport a lot of sediment toward the shoreline, but somewhere in Europe, no, it's already finished. In UK as well, in Ireland as well. So in Scotland, no, it's different because you have relief, but we have to have in our mind that this is the theory, but when you are in Brittany, we don't have relief, no tectonics. The climate is temperate. We have vegetations, of course, but my alluvial system didn't transport sediment. So depend about the catchment area, etc. So this is very important that natures and volume of sediment is primarily determined by the alluvial catchment area, its size, relief, tectonics, climate, vegetation, bedrock, superficial deposit, and human impacts. And you can use that for Java. So you have huge alluvial catchment area, important relief, tectonics is still active, climates with high precipitations, vegetations can be there but can be destroyed by human and can affect as well the trap that vegetations can play. You don't have a lot of granitic bedrock in Java. Explain that my coast is less sandy, and you have a lot of superficial deposit. You can maybe transport some deposit, but if I transport this deposit, I will not increase a lot my sedimentary budget. So let me share 2 slides, and after that I will stop and I will open the questions sessions. Then
Excuse me,
in
David.
the theory, yeah.
I think we have 10 minutes left.
Okay, I can stop now if you want. Huh?
If you want to continue for 10 minutes, it's okay.
Okay, I continue.
Okay.
Okay, I continue. So you have over there rivers. So the rivers can transport and provide sediment. And what happened after that? So after the transport, you can build deltas. This is the case. And with the wave, if the wave is coming on the right side, can transport and rework all the sediment from the land and start to build maybe a beaches system over there and transport in the offshore area the fine particles. This is summarized over there. So in the first case, we are when the reverse mouth passing is really important. In the second case, we have a shore face bypassing. Between the coast and the offshore zone, we build a barrier. This is a barrier with an inlet where the currents can be very strong. And in this case, we can have this barrier built in by storm or thanks to the wind as well. And we can observe in front of the barrier sand eroded from inland, transported toward this area. In front of, we have some ravinement that we can observe in the shallow part. And at the back of the barrier, we have look like a lagoon. So it's very common, this type of system in the world. I will show you later on some example. This is again the theory. What you have to understand and to learn, it's only the concept and where I can storage the sand, etc. Where are all the compartments along the coast in this case. So the factors that determine the role played by each of these processes include density contrast between the rivers and basin waters. So if the rivers has in the upstream part a very huge catchment area, will depend again about which type of sediment are coming along the coast, donc grain size. Is it cross deposit, fine deposit, water depth? Because again, sometimes in Java Sea it's very shallow, but sometimes you don't have the platform, the continental platform can be very narrow, and very quickly the depth is very high. Will depend about the water discharge, and of course will depend about the inflow velocity. Next slide, and I will finish maybe over there. So we have the rivers, and about from the rivers which type of consequences we can observe. In this case, we have fresh water are going, and we can observe here a barrier, a frontier between the fresh water and the salt water from the oceans. In this case, because we cannot mix very quickly, we have a stratification explaining the presence of a bar crest just in front of these rivers. We have a lot of example, and we can change the grain size, velocity, and we will see different type or different combinations around the world. In this case, we don't mix the water, fresh water and salt water. We can see these frontiers. In this case, you can observe that there is a better balance between the water from land and from offshore. In this case, we have a lot of the grain size is bigger, and we can observe different type of deposit. So you can observe over there the complexity of behaviors of sediment distributions in inertial dominated reversements, frictions dominated reversements, buoyancy dominated reversements. When we are talking about Java, we are mostly in this case. In this case, in Java, can change if you are maybe nearby a zone in the southern part when the relief allow to have a cross sediment supply. Okay, thank you for these first lectures, and I will open for the question sessions.
Okay, thank you, David. Anyone for our participant? Q&A session is open, but first, I think we have 3 questions, David, from the first chapter. Okay. For the first question is from Ilham Muhammad. One of the things that marine geoscience is looking for is offshore energy. What I want to ask you is your opinion regarding the development of ocean thermal energy development in Indonesia. Given the very contrasting climatic condition, is this method able to answer one of the goals? Yeah.
Yes. Thank you for the questions. I want to. I don't know what. Stop maybe the sharing. Okay. Sorry. Okay. So. The question is about the potential. I think I have a slide on that. Okay. Did you see the slide?
Yes, we can see the slide.
Okay, so this is the map from Marine Geological Institute. My friend Franto Novico gave me this map, and then so if we look about tidal current energy in Indonesia, you can observe that when you have a narrow zone, in this case, between Sumatra and Java, etc., you have a lot of zones that we can maybe investigate in order to measure if the tidal currents can be interested for industry, specifically when you want to put a turbine, a marine turbine, in order to do energy. Secondly, your country have a potential as well about wave energy, and we can observe as well that many places can be investigated. Then I would like to say, yes, you have probably the possibility to continue for the futures to try to develop with partner, I think, and take time as well to discuss with different partners everywhere. Even in France, we would like to develop some structures like, like that from Sabella, for example. Different turbine can be adapted in different contexts. Need time as well, because for the moment, we don't have so many results. So most of the country try to experiment the productions of energy that we can provide with this type of turbine. In my laboratory, one of my colleagues is working about that. Now, what about the wind offshore plan? We are trying to develop that as well in France. If we compare with people from UK or Netherlands, we are very late because we never start to build wind farm, offshore wind farm for the moment. Because, as one of the person tell us, the public sometimes are not I would like to say want to vote or want to explain, want to share, or want to say yes, but if we do that, are you affecting or not the marine ecosystem? What could be the consequences, etc. So, my opinion, I think that we have to try. I think it's easier to remove a turbine, by comparisons with a nuclear plant. But in parallel, people has to be educated about the rate of consumptions of electricity that we need for the country in order to maintain the peace. So we are talking about geopolitical view, but it's really important as well to discuss about that. So as scientists, I will say, yes, we have to experiment and maybe to improve all the system. And this is one of the roles that we can have as geologists or engineer from your department, I think, to help the industry to try to select the better zone for this type of future energy. But I will say that even in France, if we have a lot of oppositions for that, I think the French government, even if next 2 years we will change, we will continue to try to do something about that. And in your country, the place is very huge. So your potentials is very important. If you see the zone, it's incredible. So depend about the money that you can do. But I think for highland could be good ideas. Yeah, could be a good idea in order to be independent. And if later on oil and gas should be, if it's very difficult to get it because of the price, maybe it's a good idea.
Okay, thank you, David. I'll continue for the next question. Or are there anyone from the participant want to ask the question directly to David? If not, I will read the question. Okay, I will read the question, David, from Erlangga Svarna. About geological hazard in Indonesia, especially about soil liquefaction. How do you think about soil liquefaction potential in Indonesia, and how can we prevent soil liquefaction?
I don't have any data about that. My knowledge are very poor about. I will say probably the students or this person has knowledge about if they have knowledge. I mean, they have maybe some data, some map or article about that. I will say in order to try to follow that. Again, my very small view, it's to map all the zone and in order to overlay all the structures, then allowing to understand why this zone is liquefaction. Mean that you have to look about the circulations of water from the land or from the sea, I don't know. So the best is to maybe select an example and tell us where you have this type of issue. But in order to work on these topics, I will start like that. I will select the zone when you have a problem, and I will map and I will collect all the data that people knows. I will discuss with all the experts, even people that are not scientists and they can observe something. I will put, as I'm trying to explain to you, I will look about all the earthquakes, where are the faults, where was the last events, which type of sediment we have, do you have any borehole allowing to show the facies of the sediment, etc.
Okay, thank you, David. Okay, for the last question in the chat box by Lutfia Yasmin. Shall we continue, David? Okay, is it okay?
Okay, we can continue when.
Okay, from Lutfia Yasmin. Good afternoon, sir. I would like to ask a question about the 30th slide. could the uplifting be happen in another part except the mountain part? And so does the subsidence. Could it be happen in another part except the ocean part? Thank you.
Okay, donc she mean about thank you, Yasmina. She's talking about
The 30th slide.
yes, the first slide, I think.
Controlling factors in the positional system. I think.
Yeah. I'm trying to open it. This one, huh?
Yeah, this one, I think.
Yeah. I just forget the questions, but could you repeat, please? Could you please repeat the questions?
Okay. Could the uplifting be happen in another part except the mountain part? And so does the subsidence. And then could it be happen in another part except the ocean part?
Yeah, okay. Yasmin, you have to understand that you can sometimes observe uplift over there, but next maybe 1,000 years you can have a subsidence. So you can play. I just put arrow like that to show motions, but it's like key piano. You can have some earth or graben, depend, but can change. This place can move down. I don't know if you can see me on the camera, but can go down, and this one can be stable, and later on this one can go down, and this one look like a cliff is not. So logically, if one place is moving up, it's because something is pushing up by this way, or maybe because this place is moving down because you are putting so much of sediment. But it's not really fixed all the time. That's why mostly all the scientists are collecting database in order to try to observe what is the principal motions and to identify is this vertical motions is going in the same way or not. But can change, yes, can change. Then so here you can have uplift, and in these parts it look like subside because on the border you have big uplift. But this place can be subside, this one as well, and this one didn't move, depend. Each case is one case, I would say. After that, the most difficulty that we have to put in our mind, but it may be less difficult for you, your place, your country is moving down or up. So for me, Java is like a key piano, it's moving like that. And I think that the northern part is moving down. If I compare with this slide, let's see, I will show you. This, you see, this zone is moving down, I think. And we have an asymmetrical relief. High relief is over there. These places look like moving down. Maybe because of the deltas and the compactions of the sediment. But I have this feeling when I'm looking about, the relief and the evolutions, because most of the catchment area are going toward the north. So again, when I was talking with Najib, this is what we would like to develop, and with your colleagues, to look about all the nick point, all these things showing what could be the reason that Java is like that. And if it's subsided here, it's maybe because of, it's maybe because of the volcanoes, or maybe it's because of the the fault, and what could be the trend. But the trend can change, yes. But at the human scale, I don't think so. At the geological scale, yes, I think so.
Okay, David.
Okay.
Good. For our participants, are there any question for David? We still have 15 minutes before we close this meeting. But David, I actually have a question for you in the 30th slide. You said about anthropogenic contributions.
Mm-hmm.
Yes. How do you think? What's your opinion about that? How great should we estimate the anthropogenic contributions to sedimentation? For now?
Yeah,
Yes.
Yeah. In order to estimate, for example, just in Semarang area, what I will do, I will select one catchment basin, only one. This is what I already discussed with Najib. And I will put on this area, on my map, on GIS system, the zone where we are collecting the sand, where we have a dam, where we are putting maybe houses. I don't know, all the human role that we are playing everywhere. Firstly, this is what I will do. And secondly, I will try to estimate the consequences of that. And what I will do in the futures, I will collect sediment from upstream to downstream, and I will try to date the sediment, and I will try to as well to estimate the sediment flux, and to check next 10 years what could be the impact of human activities or anthropogenic fact. This is like that I will try to approach these ideas. I don't know if I have give answers to the students, but
yes, I think that's okay. David, we have another question from the chat box from Fadias Pugu. He's asking that in West Java and East Java, we have potential to develop energy from the wave, but why don't we don't have that in Central Java? Are there any factors that affecting?
I didn't realize that. Okay, so it was on the. Is it from this map? You mean wave, for example, west and in this place? Okay, I see. Good questions. I don't know. Is it related to the accessibility? I don't know. I can ask to Franto about that. They have identified the potential of wave energy. It's true that over there they didn't put anything. I'm sorry, I don't know. I will ask.
It's okay, but from that map, it shows that we have potential energy from the eastern part of Java and the western part from West Java, but we don't have anything from the Central Java in this map and from the last map.
Yeah, but maybe because
that's interesting.
Yeah. No, we can ask. It's a good observation. Thank you for the questions. I didn't take time to look about all the details, but yeah, it's true. It's true. I don't know. Accessibility, I don't know. Maybe they never collect, maybe they don't have, you know, sometimes the country, we have some tools offshore in order to measure the wave energy. I will ask to Fronto. I will take the questions.
Thank you very much. Okay, are there any more questions from the participants? I think we still have about 10 minutes to go before we close our meeting today. And for your information, for all participants, this is the first series of the visiting professor program presented by Dr. David Menier. First one from 5 lectures, and we have another 3 professor. And the closest one is tonight at 7:30 p.m. will be presented by Professor Magali about remote sensing. Okay, are there any more questions from participants?
If they have questions ready later on, you can send to me by email if you want.
Yeah, for everyone, if you have any question later, you can send David an email, discuss privately with David.
And I will take all the questions and we start with that if you want.
Yeah.
Okay, David, we still have about 9 minutes. So maybe I will ask a question. I'm not sure it's already asked by another participant, but you already explained about the coastal plain is very crucial in the depositional system. But you know that in the area of the coastal plain, human activities is very maybe housing and then another activity in there. So how you know that it's the problem to us maybe in Indonesia and another country. Do you have any idea how to protect the balance of the depositional system? So the maybe it's already also affected to geohazard. You know about flood, and then about the maybe a wave and etc. So maybe you have you know how, or maybe you something to think about that to make it balanced to fix that problem.
Yeah, I'm just trying to find a slide that Elmi gave me last time. Well, never mind.
You know, it's difficult to make people to move from that area, from the coastal plain.
Of course, I understand that everywhere is like that. Yeah, I mean, that's why I say when I said we have to educate people, I'm thinking the futures. By today, we have to start and to explain because I can understand that a guy that he was born there, he didn't understand what happened sometimes. So I can accept that. And we can accept that people, they don't want to move because they don't have money to have another houses and the place is very difficult to get, etc. So we know that we have to adapt. But at least when you come from government, you have to help the people and you have to protect people. So safety, it's all the time in our mind. So I consider that maybe what we can do in your case, I think that we have to try to limit to have new houses nearby the coast. This is what we have already made in France. But it's not same case everywhere in France as well. You know, some zone, the people in the northern part of France, they don't think like people in the southern part of France. So it's like in Java, you have West Java, Central Java, East Java, etc. And we have our cultures. So we have to care about the cultures. We have to care about your sensibility, your susceptibility, your emotions related to the place where you was born. But we cannot avoid what happened. Then I will say maybe we have to sacrifice a few zones and to protect few zones, but to prepare people as well to be sure that we have enough monies to pay that. And in parallel, we have to give back to the nature place for ecosystem like mangrove, because mangrove play a very important role as a buffer. Because if mangrove are growing, they are growing not only laterally, but as well vertically. And mangrove with the forest and the tree that we have there can protect people, can protect back place. So I will try to balance that and to sell this business. Okay, human, you want to live there? Okay, we can try. But in parallel, we have to maybe come back like in the past and to build again a mangrove system, our ecosystem, and stop to destroy this ecosystem. This is what I think, Najib.
Okay. Yeah. Thank you.
Okay, thank you very much, Pak Najib. We still have 3 more minutes, but I think we can close this lecture.
Okay.
This moment, okay. But before we close this meeting, please allow me to summarize this lecture first. First one is we learn about tectonic setting and history in Southeast Asia, from Paleocene to present day, and we learn about history of how Java was formed with its volcano and coastal plain characteristics. Then we need to monitor observation in order to improve knowledge and also multidisciplinary approaches and techniques and required to enhance our skill. And then there are factors that control the positional system. One system might differ from each other. And then transgressive and regressive progradational coast under varying conditions of tidal power and wave power, and of marine and fluvial sediment supply. And lastly, controlling factors responsible for distributions and shale marine and sedimentary along sandy rocky coast. Okay, thank you for David Menier for your time and for your knowledge for today.
Thank you so much.
Thank you, David. Thank you, Pak Najib, and for all participants. Do not miss the next chapter from David. The schedule will be informed later. I think we can close now. Thank you, David. Thank you, Pak Najib. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih.
Terima kasih.
Terima kasih. Terima kasih. Thank you, David.
Yeah, Najib.
Yeah, thank you.
See you in the next lecture.
Yeah,
see you
Najib,
then.
maybe you can
Lesson.
call me another. I can call you, Najib?
Yes, of course.
Okay, I will call you.
Yes,
Okay,
absolutely. Okay, thank you.
see you. Bye bye.
See you.